When discussing these notes in class, we got through just sequences that are arithmetic and through this example 5, and we left off with sum of an arithmetic series. So remember, a series is when you take the values of a sequence and add them up. So you end up with basically just, instead of the list of values shown in this manner, 2 plus 4, or 2, 4, 6, 8, 10, which is in this case the series made up of all even numbers. Instead of just listing them with a comma, you would add them in between. All right, so if I wanted to show that series, it would be 2 plus 4 plus 6 plus 8 plus 10. All right, and of course, if you add all those up, you get a value of, what is that, 30. What is not shown here is what this would look like in summation notation. And remember, summation notation is the sigma. Sigma, as I goes from usually 1 to n of some formula a sub n or a sub I. If I use I as my index of summation here, then I would represent my formula inside here with I. Again, all this was discussed in the last formal notes on 10.1, but in this case, I want to show it as a quick review for this practice with arithmetic series. So if I wanted to add up the terms of this series, first of all, let's recognize that it is arithmetic, because in order to get to the next term, all you're doing is adding 2. So you're adding the same value every time. That value 2 is what we call the common difference, right? So if I add 2 and get 4, 6, 8, 10, and I stop with 10, clearly 10 is the fifth term, 1, 2, 3, 4, 5, and 2 is the first term. So if I was going to write this as a sum with sigma notation, I would start with the first term and end with the fifth term. And then the question is, how would I get to the next term? Well, in order to get to the next term, how would I represent the next, the general term? Not how do I get to the next one. How would I represent the general term? I need a representation for the general term a sub I to go here. So to find a sub I use that formula that we discussed in the previous notes, or in class. I use this formula here. Since this is an arithmetic sequence, I can come up with a general term using the formula for the general term. In this case, I have the first term, so a sub k is actually a sub 1, and that value is 2, the first term of the sequence here. And then I'm going to add to that n minus 1 times the common difference, which is 2. So if the common difference is 2, then this becomes 2 plus 2n minus 2, which simplifies to just 2n. So my general term, this term here, is the same as a sub n. Notice I used a different variable, but that's only because in my sigma notation, I'm letting my index of summation be I. It's just a notation change. It's not a big deal. We generally like to have n be the upper limit of the sum instead of the index of the sum. So I could just change this to I if I want. If I change that to an I would change this to an I, which means the summation formula becomes the sum from 1 to 5 of 2i, right? And so if I is 1, I get 2. If I is 2, I get 4. If I is 3 for the third term, I get 6. If it's 4, I get 8. And if it's 5, where I stopped, I would get 10. So this formula represents this sum. I found my formula by using the formula for the nth term, the general term of an arithmetic sequence. Okay? So that could be plugged into the calculator now. If I did not have all of the terms and couldn't add them up very easily, we can just look at this and say it's 30. But if I didn't, if all I had was this, I could plug that into a calculator and evaluate it. All right? That is one way. This is the more formal way. The sigma notation is how we would generally represent any series. If you're adding up the terms of a sequence, you use the sigma notation and you show the sum in this manner. However, specifically for arithmetic series. This formula could also be used. So this formula is equivalent to what is happening here if we let n be 5. All right? So this formula is kind of where we're going to live. While we don't have to, we could still always just use the sigma notation stuff. This formula is what they want us to use going forward in these notes. The formula represents what we call a partial sum, meaning the sum of the first n terms of a series. All right, so example 6 says, find the indicated sum of the arithmetic series. The indicated sum here is s sub 18. So they want us to find s sub 18. Notice then that n, the n value is 18. For this particular series, notice it is a series because we have pluses in between, plus, 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 and so on. So they're adding up terms. They've told us that it is arithmetic, which means to get from one term to the next, we know that we are doing the same thing every time. We are adding some number. In this case, we're adding a negative number. It looks like to go from 13 down to 2, we have to be changing by negative 11. So the negative 11 is being added every time. That's our d value. d equals negative 11, our common difference. Then, step 2 says find the 18th term. Well, why do I need the 18th term? Because the formula for s sub 18 requires right here that you have the 18th term, a sub 18. All right, so let me rewrite that formula down here. S sub 18 would be equal to 18 times the first term, a sub 1. In this case, the first term is 13. All right, so 13 plus the nth term, a sub 18. And then it's divided by 2, according to our formula here. So if I wanted to add up, if I had all 18 terms here, now of course I could get all 18 terms. I could just keep subtracting 11, subtract 11, subtract 11, and get all 18 terms and then add them up manually, but that would be a bit of a bear. That's a little bit of a labor that I don't want to have to do. All right. So a sub 18 I can find using the formula for the nth term. And it says take any previous term plus the number of the term you want, which is 18, minus the number of the previous term you used. Usually this is the first term, so that k would be 1, times your common difference d. So this is, I do have the first term, so I might as well use it. This is 13 plus n minus 1, sorry, n is 18. 18 minus 1 times negative 11. My common difference is negative 11. And if I multiply that all out, add it together and so on, I get negative 174. Negative 174. So a sub 18 here is negative 174. All right? Multiply or simplify inside the fraction and multiply by 18, and you will get negative 1,449. That is the sum of the first 18 terms of this sequence here. Negative 1,449. All right? Again, I'm using this general formula. This formula is specific to only arithmetic sequences. This formula does not work with any other type of sequence, and there are infinite sequences out there. All right, only with arithmetic can you use this. The series notation, this sort of stuff, with the sigma, you can use this on any kind of sequence. This is a representation of the sum of the first n terms of any sequence. All you need is a formula for the sequence. So I could actually find a formula for the sequence here and plug it into sigma notation and then use a calculator to evaluate that. Let's do that real quick. So if I wanted a formula, excuse me, for the sigma on this problem, first of all, I know that this is going to be the sum from the first term to the 18th term. What I'm missing is the a sub I inside here. I need to know what that, the generic formula for this series would be. Well, that's going to be a sub I equal to the first term, 13, plus I minus 1 times the common difference, negative 11. Again, I'm using this formula up here, but rather than using n, I used I, and rather than using k, I used 1 because this k just represents, again, the numbered value of the first, of whatever term you used before the one you want. I'm using the first term, so k is 1, and a sub k is the first term, 13. All right, I keep saying that, but that's an area where I see students get confused. So if I simplify this, it gives me 13 minus 11i plus 11, which simplifies to negative 11i plus 24. So my a sub I here can be replaced. I'm going to erase it and write in instead negative 11i plus 24. This formula is a general formula using I as our index of summation, is a general formula for the sum of the first 18 terms of this sequence. So I could take this and plug it into the calculator. We can plug it into the calculator using the method that I described yesterday. I'll scroll back up to that part of the notes. I think I wrote it in the notes anyway. Oh, no, I'm sorry. It was not yesterday. It was in the 10.1 notes. You would press math, and then you would press, once you've pressed math, you would go over to summation, which is, or down to summation, which is actually option 0. I'm actually going to use the arrow down, and then you go to option 0 for summation. Summation. And once you're there, you would get a template that allows you to type in just like this. All right. In your template, you would use X instead of I, but other than that, it would look just like this. All right. Please note, you don't have to do, last thing I'll say here is none of this is necessary. Everything I've done here, all of this sigma notation stuff, that is not necessary for these problems. These problems are arithmetic, and arithmetic series can be found by using this formula. As long as you have the first term and you can calculate the nth term, you can use this formula to find the sum of the first n terms of any arithmetic sequence. Let's move on. Find the indicated sum it wants for the series, and the series, again, we are told is an arithmetic series. So if it's an arithmetic series, then we can use the formula S sub n equals n times a sub 1 plus a sub n over 2. So I need a sub 1, which I have, that's 12, and I need a sub n. Well, a sub n, because this is S sub 16, a sub n is a sub 16, and I got to calculate a sub 16. Well, in order to calculate a sub 16, I take the first term, which is 12, and add to that 16 minus 1 times d. So I need d. What is my common difference? Well, since it's arithmetic, it looks like we are going down by 5 each time. So d is negative 5. You're going to get to hear my dogs fighting over here. So if d is negative 5, then simplifying here gives me negative 63 for my a sub 16. All right, so now I can go straight to that formula. S sub 16 is equal to 16 times 12, the first term, plus negative 63, the 16th term, divided by 2. All right, and that equals negative 408. Negative 408. There you go. All right, pretty straightforward. Again, I could, if I wanted to, I could use the general formula for finding the nth term or the ith term and come up with a sigma notation for this. And I think the key on the portal probably has this notation and shows how to do that as well, but I'm going to skip that for this problem. All right, moving on. This one says evaluate the sum. All right, this time the sum has been given in terms of sigma notation. All right, which is why I've been talking about this and making sure that you're a little more comfortable with it. First thing we have to do is we have to verify, well, let me back up. Given this, you could simply plug it into the calculator, press math, go down to summation or option 0, and plug this directly into the calculator. You could evaluate that on the calculator very easily and get your sum of, what is this? The first 30 terms, from 1 to 30, right? So this is equal to S sub 30. What we don't know, it's a partial sum of 30 terms. What we don't know is what kind of sequence this is. Now, I know straight up, because 6i minus 11 is a linear term, I know that this has to be an arithmetic sequence. If it's an arithmetic sequence, then I can use the same formula here, the same formula for the first n terms of the arithmetic sequence. All right? To verify that this is arithmetic, I would find the first couple of terms and just compare, see what's happening. So if the first term is, if the general formula for first term is 6i minus 11, then 6 times 1 minus 11, 6 times 1 minus 11 leaves me with negative 5. And the second term is 6 times 2 minus 11, which gives me positive 1. And the third term is 6 times 3 minus 11, which gives me 7. All right? And so it looks like, if I kept going in this process, it looks like I'm just adding 6 every time. So I'm confirming that this is in fact arithmetic and the common difference is 6. Now that I know that this is absolutely an arithmetic sequence, I can use the formula for the first n terms of the arithmetic sequence. So S sub 30 would be equal to 30 times the first term, a sub 1, plus the 30th term, a sub 30, over 2. All right? And again, that's direct application of this formula here. So, since I need a sub 30, my next step would be to find a sub 30. A sub 30 is equal to a sub 30 is equal to the first term, which we know, negative 5, plus 30 minus 1 times the common difference, 6. So the 30th term, if I calculate that, is 169. All right? Or, just as a little side note, I didn't have to use that standard formula. And by this point, I hope that this is standard. That formula that I used is the same as this, all right? Or if I go all the way back, this, all right, the a sub n term. Let me back up, there we go. I didn't have to use that. I actually had a formula for the nth term already simplified right here, all right? We know that the nth term or the ith term, doesn't matter what you call it, the nth term or the ith term, is 6i minus 11, so I could have just plugged 30 into that. And 6 times 30 minus 11 will give me 169. All right, so this was another way to do it. All right, moving on. So now that I have the first term, negative 5, and the 30th term, 169, I can find S sub 30 using this formula. All right, so S sub 30 is equal to 30 times the first term. Again, we know that first term is negative 5, plus the 30th term, which is 169, over 2. All right, and simplify that, and you will get 2,460. And there you have it. Again, I could have just plugged this straight into a calculator, and I would have gotten that same value, 2,460. But using the formula for the partial sum that is specific to arithmetic sequences, I would need the first term, the 30th term, and then I could plug straight into this and get the same number. All right, there you have it. That is series, specifically arithmetic series. See you in the next video.